This is R.D. Sharma solution, class 12, chapter 10, differentiability. Exercise 10.2. If f is defined by fx is equal to x square, find f dash 2. So that means f dash means differentiation, derivative. So wherever this x will be after differentiation, we'll put 2. Direct differentiation is 2x. That is d by dx of x square is 2x. But that is supposed to be learned in the chapter of differentiation. We are discussing the differentiability right now. So we'll do it by the first principle. And we already know that because it is a polynomial, this polynomial function is everywhere differentiable. So fx will be differentiable at x equals 2, right? So let us check it and find out the value as well. So what do? We write this f dash x, x is 2 here. So at 2 we have to check. So when we were discussing how this first principle came, what we used to do, fx minus fc by x minus c, we used to take the left hand limit, that is the left hand derivative, and then the right hand derivative, we wanted to show that both value comes same. And that is how we arrive at the final formula or the expression for the first principle. So the differentiability, as I just indicated you, 2 minus h we would put, 2 plus h we would put. This is what we used to do, similar to the continuity theory. So this all has come because of that only, which we have already discussed in a stretch in detail. So I am putting this, I am using the first principle directly. So it will be fx plus h minus fx divided by h. Limit h tends to 0. That is going to be f dash x. Okay. So this basically if you put 2 plus h also the same thing is going to come. That is the right hand limit or left hand limit, same thing is going to come. So now we have this f2 plus h minus f2 by h. In place of x, just change it by 2 plus h. So 2 plus h whole square minus f2, that is 2 square. And denominator I will just write later. And 2 plus h whole square is a plus b whole square, a square plus b square plus 2ab. Then we have this minus 2 square, which is 4 only. So we can just cancel these two. H square plus 4h, you can take h common from here. So please remember, limit h tends to 0 and h in the denominator is always there. I am not just writing just because I just don't want to waste the time and keep the effort as low as possible. Because main idea is for you to understand the logic or reasoning. Okay, denominator was already there h, so you can just cancel this h and h. Numerator, denominator, and h tends to 0, so this is going to be 0, you get 4. So f dash 2 is what? 4. That's the answer. If f is defined by fx, this is a quadratic equation and a polynomial, of course, and you have to show that f dash 5 is equal to twice of f dash 7 by 2. So this 7 by 2 or 3.5 you can say. So 7 by 2. So what we'll do, we'll just find out the f dash x. And then we'll put first the value 5 and then we will put the value 7 by 2. And then we'll try to see whether it comes twice or not. Okay. So f dash x, simply as I said in the first question also, f dash x is simply fx plus h minus fx divided by h. This is the differential or differentiation or the derivative. So now we'll not put the value right now. We will use the quadratic equation in order to get a solution of this quadratic equation. And then we will put this 5 and 7 by 2 value as and when required. Right? Okay. So this fx plus h, we have x plus h, so just replace it by that, x plus h whole square minus 4 into x plus h and plus 7. This is, always put the first term in the square bracket because it is a bigger expression. We don't want to confuse it with the second one, which is only fx, which is x square minus 4x plus 7. And divided by h is also there, and limit h tends to 0 is also there. So limit h tends to 0 and division by h, I am going to write it later, but for you, you have to write it every time, every step it has to be there. So we'll just open this, a plus b whole square, so x square plus h square plus 2xh and minus 4x minus 4h plus 7, and now change the sign because negative is there, so minus x square plus 4x minus 7. X square you can cancel, you can 4x you can cancel, 7 you can cancel, and what do you get? H square plus 2xh minus 4h. Now you can take h common because h is everywhere. H you take common, h plus 2x minus 4 it will be. Now in the denominator it was already h as I told you, and limit h tends to 0 is also there. So just replace it by limit h tends to 0. Okay, this is all. This I am not just writing, you have to write it at every step. H gets cancelled, apply the limit, wherever h is there, remove that term. 2x minus 4, f dash x is 2x minus 4. Now we will put 5 and then 7 by 2. So f dash 5 will be 2 into, in place of x, replace it by 5, you get 5 to the 10 minus 4, that is 6. Now f dash 7 by 2. So this is going to be 2 into 7 by 2 minus 4, 2 gets cancelled, 7 minus 4 is 3. 3 and 6, 3 to the 6. And this is what is being sought in the question. 6 equals 2 into 3, hence proved. Show that the derivative of the function f given by, so this is the function x equals 2 and x equals 1 and 2, these are equal. The steps will remain same. Same thing you have to do. Let me write it again. The first principle, f dash x is given by fx plus h minus fx divided by h. Limit h tends to 0. So this and this always will be there. I will not be writing it. The numerator is important because ultimately the whole computation lies in the numerator in first principle, right? There will be certain problem if you just miss a negative sign or some term. So 2x plus h whole cube, so this is 2x plus h whole cube minus 9. In place of x, write x plus h plus 12 into x plus h plus 9 minus. Now you just have to write this fx because it is fx minus fx. So 2x cube minus 9x square plus 12x plus 9. Okay. So just numerator I am taking right now. A plus b whole cube is what? A cube plus b cube plus 3ab a plus b. This is the way I remember. You can also remember, or if you have another way of remembering, you can just open this. 2 is already there. So just open this, x plus h whole cube. So x plus h whole cube is a cube, that is x cube, plus h cube plus 3ab, 3 into x into h, and a plus b, that is x plus h. You can also open this, x cube plus h cube plus 3x square h plus 3 xh square. And since we have 2 also there, so multiply 2 and then write it here, 2x cube plus 2h cube plus 3 to the 6, so 6x square h plus again 6xh square. Now we have 9 here. Let us open this x plus h whole square here first. So x plus h whole square, a plus b whole square will use a square plus b square plus 2ab, and 9 is already there outside, so 9x square plus 9h square, 9 to the 18. Now since negative is there, so you can just change the sign and add it with the numerator. So minus 9x square minus 9h square minus 18xh plus 12x plus 12h plus 9 minus, Since you have a negative sign in front of fx, you can just change the sign and write it. Minus 2x cube plus 9x square minus 12x minus 9. Okay. So most of the things are going to be cancelled, as we saw in the previous questions. This gets cancelled. 9x square also gets cancelled. Minus 12x is also there. Minus 9 is also there. So you have 2h cube plus 6x square h. All of them are having h. So I'll take h common and then I'll keep all the values inside except one h. And in the denominator it was h already. I'm not writing it, but let me show you what terms we get. H square plus 6x square plus 6xh minus 9h minus 18x, and then we have plus 12. Okay, so all are done. Now let us write this denominator h and limit h tends to 0. This gets cancelled. Remove all the term having h. This one also. So what do we get? 6x square minus 18x plus 12. So this is your differentiation. This is your first principle. F dash x it is. Now the question is saying at x equals to 1 and x equals to 2, you are going to get the same value. So let us put it. F1, 6 into 1 square, that is 6 will be minus 18 plus 12. F2 is what? 6 into 2 square. So 6 into 2 square, that is going to be 4, minus 18 into 2, that is going to be 36 plus 12. So 6 plus 12 is 18, 18 minus 18 is 0. 6 plus 4, 6 4 is 24, minus 36 plus 12, 24 plus 12 is 36, 36 minus 36 is 0. Okay? So 0, 0, and they are saying the same thing, so we have also proved it. They both are same. Differentiation is equal. If for the function of phi x, you can also call it as psi it is called as. It does come from Latin or Greek, I don't know, but it is phi. Let me pronounce it as phi x. Okay. So phi x is this is the function. Phi dash 5 is given as 97. Find lambda. Basically, you have to find out the differentiation. And since we are in the chapter of differentiability, we'll use the first principle. Same thing we have to do. Previously it was f, now it is being replaced by phi. Nothing else. So phi dash x will be f, not a f, phi x plus h minus phi x divided by h. What is phi x plus h? Replace x by x plus h, lambda x plus h whole square. H in the denominator, right? So lambda x plus h whole square. Okay. I'm not writing limit h tends to 0 and h in the denominator. I'll just use it when it is required. But you have to write it, okay? So lambda x plus h whole square plus 7 into x plus h minus 4. And then we have minus fx is, phi x is lambda x square minus plus 7x minus 4. Just open it. It will be x plus h whole square. A square plus b square plus 2ab. And this is lambda, so lambda x square plus lambda h square plus 2 into xh lambda plus 7x plus 7h minus 4 minus lambda x square minus 7x plus 4. Numerator only. Cancel these out, which are same. Lambda x square plus 2 lambda xh plus 7h. Take the h common. Lambda h plus 2 lambda x plus 7. Now you introduce, that is the h was already there. I was just not writing it. So h is in the denominator. Limit h tends to 0 was already there. H gets cancelled. Now replace all the term with h. Remove all the terms with h. So you get 2 lambda x plus 7. This is your differentiation. Now this value, when x is replaced by 5, it is going to get use 97. So phi dash 5 is 2 into lambda, in place of x write 5 plus 7 is equal to 97. This is going to be 10 lambda plus 7. 10 lambda, just write it 10 lambda. 10 lambda plus 7 is equal to 7 I am taking on the right hand side is going to be 90. So lambda is going to be 90 by 10, that is going to be 9. Lambda is 9. This is your answer. Alright. Now this fx is the function find f dash 4. We have already done it, the question just now. So I'll just give you again the idea, that is just replace x by x plus h and subtract it with the original function, divide it by h, take limit h tends to 0, that is the whole concept of first principle. Take h common and then divide it, because division h is there, cancel it out. Wherever h is there, just remove that term. Whatever is remaining is your differential. And finally put in place of x 4. You get 1, 1, 2. Find the derivative of the function f defined by fx equals mx plus c at x equals 0. Now what we do generally is, the question is put in front of us and we just try to solve it. But the thing is that this is a line, y equals mx plus c. You must observe and understand that this is a straight line and the derivative of this line will be m. Why? Because derivative is all about finding the tangent or the slope of the tangent. So y equals mx plus c is a line, c is the y-intercept. If y equals mx, that means it is passing through origin. But y equals mx plus c means you have some c y-intercept. So now finding out the differentiation of this, what do you get? Fx plus h minus fx divided by h. Same thing we are going to do. Limit h tends to 0. The procedure remains the same. This is going to be f dash x. Let us see whether it comes at m or not. So m into x plus h plus c, this is our first term. Write the fx terms which is mx plus c, and just open it first, then we'll divide it by h later on. So this is going to be, and limit h tends to 0 is also there. So mx plus mh plus c minus mx minus c, mx gets cancelled, cc gets cancelled, you have mh divided by h, limit h tends to 0 is already there. Now you can cancel h, you will not be able to apply a limit because this is a constant, m is a constant. Now this result is very important. Let us analyze it. See, what is f dash x? What is f dash? What is derivative? It is nothing but the slope of the tangent. The question is, it is itself giving us the equation of the tangent. And you have to find out the derivative of that tangent, and that has to come as the slope. Tan theta dy by dx. Right? So this differentiation should come as m, and that is what we have got. Right? So at x equal to 0, it will remain as m. Why? Because there is no x. Because slope is dy by dx, which is m, which is tan theta, which is, you can say in a nutshell, the idea or the crux or the theory of differentiation. If you understand this concept, everything will be clear to you. X equal to 0 doesn't matter because there is no x here. It is a constant. It will remain as a constant. At any point, x equal to whatever, it doesn't matter. Because it will be m. Because slope doesn't change. Examine the differentiability of the function f defined by this. So this solution will be through f dash x. Till now we haven't heard about or learned about the differentiation, proper differentiation, but differentiability we know. But why we cannot use that differentiability? Because differentiability is fx minus fc by x minus c limit x tends to c. This we already know after all these questions we have done. And in this number line, let me show you the points where we have to check. We have minus 3, negative 2, and 0 and 1. Minus 3 and 1 we cannot check, because when we go to the left hand limit for minus 3 we don't get anything. When we go right hand limit for the 1 we don't get anything. So we can only check for negative 2 and 0. Now I'm just going to tell you how do we fail. That's why we have to opt for f dash x. So let us say I'm checking at x equals minus 2. So left hand derivative minus 2 minus h I'll put, because we are just going a bit backwards to minus 2, and x equals minus 2 minus h. So in place of fx I have to use 2x plus 3. And when you put fc, that is f negative 2, this equality sign is here, so you have to use 2x plus 3 function here. So remember why I'm doing this. It is going to fail. I'll show you how it fails. So 2 into negative 2 plus 3 is going to minus 4 plus 3 is going to be negative 1. So negative positive. And we have x minus 3x. Of course, we have to keep it as a negative 2 negative h, minus 2 minus h, that is. And minus it becomes plus. So I'm replacing actually minus 2 minus h here. I'm not doing RHD just because I just want to show you what's going to happen. So minus 2 minus h plus 2 in the denominator, you get only negative h. In the numerator, you have minus 4 minus 2h plus 1 divided by minus h. You are going to get minus 3 minus 2h by minus h. Now limit h tends to 0 will remain everywhere. So 3 plus 2h by h, because negative I have taken outside and it gets cancelled from the denominator. So h tends to 0. When you apply 0, numerator will be 3. But what about 0 in the denominator? So it will not work. Similarly, if you do RHD, I've already done it. So I'm just claiming it's not going to work. For that, you have to do what? We have done in earlier questions also the same thing. So we have to check at minus 2 and 0. So fx is already there with us. What is this fx? Fx is 2x plus 3 and x plus 1 and x plus 2. Now f dash x, same here I'm going to find out. Okay, so this 2x plus 3 and the differentiation of 2x plus 3 is 2, x plus 1 is 1, x plus 2 is 1. That is d by dx I'm finding out. For example, let me tell you about 2x plus 3, 2 d by dx of x and plus d by dx of 3. You know d by dx of 3 is 0. D by dx of x will be 1, so 2 will come. Similarly, 1 and 1 for the other two boundaries also. Now the range will remain same. Let me just call them as A, B, C. I would not like to write again. So this is A, B, C. Okay. Now left hand limit and right hand limit for the derivative we are going to find out. For f dash x, left hand derivative and right hand derivative we are going to compute. So x equals minus 2 will check, x equals 0 we are going to check. We cannot check from negative 3 and 1. And this left hand limit for the derivative, we are not going to write LHD, it is LHL for the derivative. So it will be limit x tends to minus 2, and here we'll write limit x tends to minus 2 plus, minus 2 minus and minus 2 plus. Okay. So when we have minus 2 minus, that is you are on the left of negative 2. So you have to take 2x plus 3 as the function, and differentiation of that is 2. Because we are going to use a differentiation. On the right, when you take that will be 1. Because you are up ahead minus 2. So LHL and RHL for this derivative is 2 and 1. Because these are constants only. So they are not matching. So it is not differentiable at negative 2. Let us check at x equals to 0. LHL and RHL for the derivative, right? So x equals to 0, again same thing we are going to write, limit x tends to 0 minus, that is on the left of 0, and limit x tends to 0 plus, that is on the right of 0. So 0 minus, that is this x plus 1 function we have to use, but the derivative is 1, we already found out. And when we go up ahead 0, it's going to be x plus 2, but the derivative of x plus 2 is 1, which I told you just now. So when we find out there is no x, so even if you apply limit, doesn't matter, 1 and 1 will come on LHL and RHL. But they are same, they are exactly similar. That means that at x equals to 0, it will be differentiable. Write an example of a function which is everywhere continuous but fails to be differentiable exactly at 5 points. So there are various functions which we have already seen that they are continuous but they are not differentiable. But modulus x is a very safe function. We already know about it. So understand it very well because it is going to be used in the next question. Okay. So y equals x, when you have a line called y equals to x, it will be a straight line passing through the origin. But when you have the modulus, there will be no negative. That is, on the negative y quadrant, there will be nothing. It has to go to the positive quadrant. So because mod x will always give you positive result. So y will always be positive. There will be no negative y. So you have to take it up. So, it is continuous. You don't have to see y equals mod x, 5 points, mod x is there, so you just add 1, mod x plus 1. You can add my mod x plus 2, x plus 3 and x plus 4 just to make these as 5 points. So this is the best function which we can come up with. And so this is continuous. Continuous means that you don't have to pick your pen up anytime. So you are just drawing it, and you can draw it. So this is continuous. Differentiable means at particular point, the m or tan theta should not change. So this is these are the concept behind it. See, you can also take x minus 1, x minus 2, x minus 3, x minus 4. That is the same thing. So let me just give you a more idea about it if sometimes this kind of question comes. Y equals x minus 1. That is the second term I am taking. When x is 0, y is minus 1. Y is going to be negative 1. Okay. And when we take y equals x minus 1, that is, when you take modulus, it is going to go up. But when y is 0, x is going to be 1. Okay. Y is 0, that is x-axis. X is going to be 1. So we are talking about this. So this is not the actual point. This is not the actual point. This will be the actual graph for x plus 2. And similarly, you have again this one x minus 2, x minus 3, x minus 4. So this is how you can comprehend why we have used this. Discuss the continuity and differentiability of fx. And this is log. See, first is the modulus. Inside that we have log, inside that we have modulus x. So there are multiple things which are going on here. So all of the thing is modulus x we know till now. We have done a fair number of questions. What about log? If you are aware of log, then only you will be able to appreciate and solve this question. So you need to learn and you need to be aware of log. Okay. So this is the solution which I presented for those who don't want to see the solution. They can just have a look and a reference and they can do it. But for those who need help, this is the log function. So this is the graph and you know about this graph. See, log x is nothing but if log x equals to y, say, and base is e, base is very important. So it basically e raised to the power is x. This is the log. If you take the log of both sides, e raised y equals x, that first line will come. So when you draw the graph, it is going to cut the x-axis at 1, 0. That is how it changes. That is, when you are actually putting modulus, so you cannot go to the negative y-axis. You also always have to come to the positive y-axis. The modulus will always give you positive result. This is normal log x. So the line which is below the x-axis, that is to the negative y-axis, won't work. That is, if you take log x or log minus x. Log x you saw the function. And log minus x will be what? The same function mirror image on the left hand side. That is, log x. This is negative x-axis. So positive x-axis log x, negative x-axis it is log minus x. So same graph will be drawn but on the opposite side. Okay. I must tell you, you need to know log before going to solve this question. Okay, so now here we have, I hope you got the idea of log x function and log minus x function. But this question, there will be certain points where I am going to do something. Beforehand, I would like to explain it. See, when you put a modulus sign, I told you just now in one of the question, or otherwise, y equals modulus x. When you have y equals x, there will be a line, straight line passing through the origin. But when you have y equals modulus x, there will be no negative value. So that particular line below has to go up. So these lines which are going below, they have to come up for log x. Here, like this. Same line which you show here, see here, it will go up. Okay? And don't worry about my handwriting, it's terrible, and drawing most terrible. Okay, so now this line, the line which is below has to go up because we have put a modulus. Modulus will always give you positive results. So positive y-axis you will get, no negative y-axis. So this line, just cancel it out, it has to be made up. Similarly, here also on the left hand side, the negative side, you have to clean it off because you are putting a modulus now, and it has to go up. So in order to make this has to go up, we have to multiply it by negative sign. That is what we are going to do. So 1 0 and minus 1 0 are the points which are of our concern. But this graph is going till infinity. We don't know where it goes. So we have to talk about and to take into account negative infinity and infinity also. So minus infinity to negative 1, negative 1 to 0, 0 to 1 and 1 to infinity. These are the four partitions or four you can say intervals which we have to imbibe, which we have to consider. Without that, we will not be able to solve this two modulus and log question. So I'm just clearing it up. Let us solve the question now. I hope you have got the enough base so that you understand this question, how we are going to solve it. So mod x first. What is mod x? Modulus x will always give you positive result. It will be x if x is greater than or equal to 0. If x is less than 0, it is negative. So you have to put a negative in front of it. So in order to make it positive, so it will be negative x. This we have done 100 times. But I told you with the graph that you have to consider there are certain intervals that you have to run. You just can't say greater than 0 or less than 0. No. You have to divide this modulus x result in 4 intervals. Negative 1 to 0, 0 to 1, but 1 to infinity and minus infinity to negative 1 also has to be included. But whatever is below 0, it is going to be x. Whatever is above 0, it is going to be negative x. It will remain same. It doesn't matter. Just interval we have increased, but the points are same. We know for mod x, it will be x for anything which is 0 or greater than 0. So minus infinity to negative 1, for this left hand side, since it is going to be negative, so you have to put a negative sign here, negative x. Similarly, from minus 1 to 0, it will be again negative x. See, anything below 0 is going to be negative. Please remember that. Anything below 0 is negative. Negative x. So, this is negative x, which we have done in the previous one also. If you talk about whole interval from 0 to infinity, 0 to negative infinity, it will be negative. From minus infinity to minus 1, minus 1 to 0, it will be minus x only. When you go above 0, so there are two intervals, 0 to 1. When you are between, x is between 0 and 1, then you are going to get positive. X value is positive because x is positive in the number line you can see. So you have to write, don't write positive, it will be x only. But when you go up 1 to infinity, again, when you are going up 0, it will be positive. So 1 to infinity will always be positive, right? We are just making the intervals, more intervals, just to encompass that log version. This has been done for the log thing, okay? So this, I hope you got the idea. This is very important. This is very important. There is one more thing which is coming, but I'll just explain it. First thing is clear. Now next one is, you have to put a log. So log is simply put log. Log is just like that. Just put log. So log of this, log of x. For all these 4 interval, we have just made it as log. It doesn't matter because there is no modulus, etc. But when you put a modulus in this log modulus x inside a modulus, it will behave like modulus x only. It will be negative, it will be positive. I told you, whenever you put a modulus x, there will be no negative y value. So you have to put it, it has to be positive. So in order to make it positive, you have to multiply it by negative, minus. Here also, this graph is going below. But when you put a modulus, when you have to take it in the positive direction, positive y-axis, you have to multiply it with a negative. So when you just, whenever we apply the modulus, when we apply this modulus, what will happen? When modulus log modulus x, when we'll do, so what all will have a negative sign in front of it? Remember the graph, what point of graph was below the x-axis? It was from -1 to 0 and 0 to 1, because minus infinity to negative 1 was up, 1 to infinity was up, so you don't have to worry about that. Whatever it is there, write it. But -1 to 0 and 0 to 1, negative 1, I am placing a negative in front of it. This middle 2, 1, negative 1 to 0, 0 to 1, negative 1, that is why where I have to put a negative sign. You have to put a negative sign. Got this? These are the 4 intervals we talked about. If you are well versed and you understood this, the question is easy like a cake. Okay? So we have to check the continuity, we have to check the differentiability for all these points. Basically, we have to check it for negative 1 and 0. Right? Negative 1, 0 and 1. So you have to check it for negative 1, 0 and 1. You have to do it for all. Please remember. I'll do this for one of these. I'll leave it for others for you. So we are going to check the differentiability first. So differentiability, please remember there was what partitions? It is going to be negative 1, 0. Here it is going to be 1, 0. And so minus 1 will check and 1 will check. You can check at 0, but it's not going to give you anything because log 0 is undefined. Please remember. So don't check at 0. It is undefined already. You know it. So we will check at 1 and negative 1 only. So the formula for differentiability is simply fx minus fc by x minus c, limit x tends to c. So same thing we are going to apply here. We are going to check at negative 1, x equals, now on the left hand side of negative 1 is negative 1 minus h, and the right hand side of this negative 1 plus h. Okay, now minus 1 minus h. So you are going on the left of negative 1, so you have to follow this interval. So what function you have to use? Log minus x. I hope you got this idea. Log minus x. So log minus x, that is why we have replaced minus. What is fc? C is minus 1 here. Okay. So for f negative 1 is what? The value of log, you have seen the graph also. At negative 1 and 1 it is 0. So it is going to be 0. Log 1 is actually 0. Log minus 1 is also 0. So you have minus 1 minus h in the denominator, plus 1. C is minus 1 here. So negative h in the denominator. So we have to replace this x by negative 1 minus negative h, minus 1 minus h. So log, so minus 1 minus h, but it is negative also. I'll just change the sign because it is not x, it is negative x inside the log. And what is in the denominator? You have negative h. Okay. And same thing we are going to do on the right hand derivative also. But we know this log 1 plus x divided by x, limit x tends to 0, and this is going to be 1. We know already that. This is a rule, theorem. So since you have a negative here, I told you, let me just change the sign. So minus is there. So this will be simply 1 plus h in the numerator. Log 1 plus h. So this is log 1 plus h divided by negative h. So negative, you can just take an outside. it will be log 1 plus h by h, and you can just apply that rule or theorem. So log 1 plus h divided by h, you can just have a negative in front. Limit h tends to 0. Please remember, limit h tends to 0 you have to write at every step. Log 1 plus h by h is going to be 1, so it will be negative is already outside, so it is going to be negative 1. What about right hand derivative? X is equal to negative 1 plus h. Same thing we are going to do in place of fx, but the function will change. Why? Because you are on the right hand side of negative 1. So just see negative 1 to 0, that is the interval. You have to use minus log minus x. Minus log minus x. And what was fc? Of course, at minus x equal to minus 1, the y is going to be 0. So it is going to be 0. fc is 0. X minus c. So minus 1 plus h minus of minus 1, that is going to be plus 1. This gets cancelled. You have a h in the denominator. Limit h tends to 0, you have to write. Okay, I'm not writing it, you have to write. Limit h tends to 0 is everywhere in each step. Limit h tends to 0. Okay, even if I forget, you have to write it. So now you have a minus. So you have minus 1 plus h. So it is minus x. So it is going to be 1 minus h. And denominator you have h. So limit h tends to 0. But we know that log 1 plus x by x is going to be 1. If you apply the limit h, this. So 1 minus h by minus h. So you just apply this. You need a negative in the denominator. So you have to have a negative in the numerator. So negative gets cancelled. Log 1 minus h by this formula is going to be 1. This is going to be 1. Okay, now we have applied the limit. Left hand derivative came to be minus 1. Right hand derivative came to be 1. They are not equal. That means at x equals to minus 1, they are not differentiable. This function is not differentiable at x equals to minus 1. Now, I hope you will be able to do at x equals to 1. Okay? Because it will take a lot of time to actually solve it. But the idea I have given you, same way you have to follow this procedure. Because the main was finding out the first step, which I already did. Okay. Now let us come to the continuity. So continuity also you have to check at negative 1 and 0. You can also check at 0, 1, minus 1 and 0. But the problem is the log 0 is not defined. So you just have to check at negative 1 and 1. So let us check at x equals to minus 1 or 1. Differentiability we have already checked at x equals to negative 1. Right? So we have to check at negative 1 or 1. So let us check it at 1, the continuity. I will leave that x equals to minus 1 for you. That is why I show the answer also. So that if you have any trouble, you can just refer it. So this LHL and RHL. So limit x tends to 1 minus you can write. Limit x tends to 1 plus you can write here. Now what is the function? 1 minus 1 in the left of 1. So minus log x you are going to use. And 1 plus means 1 to infinity. This function you are going to use log x. Now since x tends to 1, since you have used the function, now just apply x equals 1 wherever x is there. We used to do 1 minus h, 1 plus h, that also you can do, but it will not be required here, because there will be no untoward value if you put x equals 1 anywhere. So minus log 1, here also log 1. So log 1 is 0. So minus 0 is 0. And log 1 here also 0. So the left hand limit is equal to right hand limit. So this function is continuous at x equals to 1. Right? X equals to minus 1, I am leaving it for you. If you have any problem, the answer is in front of you. You can just have a reference here. This is the reference. Okay? I hope you got the idea. Discuss the continuity and differentiability of fx is equal to e raised to the power modulus of x. Okay. For reference, I have given you the solution. Those who want to do it themselves for them, and for the logic and reasoning for others, let us understand one by one. The first thing here is the modulus x. Modulus x is simply x. If x is greater than or equal to 0, then it is going to be x. But if x is less than 0, then because it will be negative, so you have to put a negative in front of it. For example, if it is negative 2, you have to put a negative by yourself in order to make it positive, because modulus always gives you a positive result. That is why we have written negative x, because we want to make it positive. So x and this negative x for x greater than or equal to 0 and x less than 0 is well known to us. And this e raised to the power something which is modulus here will remain the same. E raised to the power everything. It just depends on the modulus. So we will write this again. Fx is equal to e raised to the power x and e to the power minus x, depending upon whether, because when we open the modulus x, there will be two cases. If x is greater than or equal to 0, it is e raised to the power x. If x is less than 0, it will be e raised to the power negative x, right? So continuity and differentiability, what we do, we just go to the left, we go to the right, we try to show them they are equal, and then if they are not continuous or differentiable. So left hand limit and right hand limit I am taking for x equals to 0, because x is the point where it is actually getting 0. So we have x equals 0 minus h, which is a minus h, x equals 0 plus h, which is h on the right hand limit. So limit h tends to 0, in the place of x, replace it by negative h. Okay. Left hand limit, e raise minus h, because 0 minus h, which is essentially minus h only. Before that, always do this kind of thing. X tends to 0 minus, that is, you just want to show or tell the examiner that you are going on the left. That is why it is left hand limit. So what will be the function? X is less than 0, the function will be used as e raise minus x. And e raise minus x, because in the place of x you have to replace it by negative h. In place of h, replace it by negative h. E raise minus of minus of h is e raise h. Okay. So e raise h is, now you can apply the limit h tends to 0. So it will be e to the power 0. Anything, not only e, anything to the power 0 is always 1. Similarly here, right hand limit h tends to 0, 0 plus. So you are telling that I am going on the right now. So 0 plus h, that is h you are going to replace, and for that on the right the function has to be x greater than or equal to 0, e raised to x. In place of x I have replaced it by h, e raised to h, now replace it by 0, e raised to 0 is a 1. Anything to the power 0 is 1. So both are 1. So left hand limit and right hand limit both are equal to 1. You can easily say the function is continuous at x equals to 0. Along with this, you have to check one more thing, which is what is the value of the function at this point 0. f0 is what? 0 is what? E to the power 0, which is going to be 1 again. So x equals 0, continuity is established. Now we'll turn our direction towards the differentiability. Okay. So differentiability, we already, the basic thing we have already done. That is, when x is greater than or equal to 0, x is less than 0, what will be the value of e raised to the power modulus x. So now we are coming to the differentiability. Left hand derivative, right hand derivative, x, the derivative is given by fx minus fc by x minus c. C is 0 in this case. So limit x tends to c here. So x will taking 0 minus h on the left part. Right part we are going to take x as 0 plus h. That is, x is negative h here, x is positive h here. So now limit h tends to 0 minus. That's just to show that we are going on the left. And e raised to the power minus x we are going to use, because of course the function says that. And f0 is what? We have just computed f0. E raised 0 is 1. And in the denominator what will be? X minus c is 0. So you have just negative h. So just replace it by negative h in the denominator. Okay. This also, but limit x tends to 0 plus. And 0 plus means we have to fx minus fc again. The function will be different. It will be e raise x in this case, because we are going on the right hand side, which is x is greater than or equal to 0. So e raise x minus 1 divided by h. And I'll just replace x by h. in the left hand limit, x will be replaced by negative h. So it will be e raised minus of minus h, that is e raised h minus 1 by h. Here we have e raised h minus 1 by h. Now we know what we have to do. Limit h tends to 0. Remember that minus h is already there on the left hand limit. Okay. E raised x minus 1 by x, limit x tends to 0 is 1. We already know that. So when you apply this limit, here also we apply the limit. On the left hand we have an extra negative which is in the denominator. So this right hand is of course 1, but the left hand we have a negative also. So let us have a negative here. So the left hand derivative is negative 1, right hand derivative is 1. Okay, I'll just put a negative here just now because this is negative here. So this is negative. So left hand derivative, right hand derivative, they are not matching. We can just say that the function is not differentiable at x equal to 0, though it was continuous at x equals to 0. Differentiability is not established, continuity is established. Okay, so this is how you have to do this e raised to the power modulus of x. So continuity yes, differentiability not yes. So you have checked at x equals to 0 here. Discuss the continuity and differentiability of this function. So at x equals to c it is 0, at x not equal to c it is this function x minus c cos 1 by x minus c. So left hand limit and right hand limit we are going to check, and x will be, because the point is c here already given in the question, so c minus h will put on the left hand limit, right hand limit. This is the point c I am talking about. Either you want to go to the left or the right and just subtract small h, add small h, and x is equal to c plus h, c minus h and c plus h, and replace it in the place, or put it in the place of x. So x is c minus h minus c cos 1 by x. I am writing it as c minus h minus c. Here also same thing. This is c plus h. So x is c plus h minus c cos 1 by c plus h minus c. Okay. So this goes negative h cos of minus 1 by h it is. And this cos minus theta is plus cos theta. And please remember, everywhere you have to put limit h tends to 0. That I have been telling you always, that I'm not writing it just because we want to save time and effort, but you have to write this limit h tends to 0 everywhere. So h cos 1 by h on the right hand limit. Cos minus theta is what? Cos negative theta is plus cos theta. So this cos, whether it is negative or positive, doesn't matter. Since we have a negative h here, we have negative h cos 1 by h. This is h cos 1 by h. Okay. Now cos and sine, they are bounded function. How they are bounded function? Because the value, whatever you put inside theta, it will always give you the value between negative 1 and 1. Right? Let me show you here also. See, this is a sine function. It is always bounded. That is, it will be the result of sine, any theta will be always negative 1 to 1 in between. So cos 1 by h will always be, some value. But I'm not talking about that h 1 by 0 that will give you cos infinity, whatever it is. But in front of that you already have h. This is also h. That is, you already have a h in front of it. So whenever you put h as 0, whatever comes outside, 0 into infinity or 0 into undefined is also 0. Right? So you have a 0 on both the sides because h is already there. Both where you have cos 1 by h is a bounded function. That is a separate discussion. But h is already there. So the limit exists. Limit exists or not? Because 0, 0, both sides we get 0. Okay. So now let us come to the left hand derivative and right hand derivative. Let us see that. So this fx minus fc by x minus c, So let me just show you how this left hand derivative works. X equals c minus h will put here, x equals to c plus h will put here. So you will just see what you are going to get. You are going to get what? This is x equals c minus h, of course. So let us put x equals to c minus h here. And when we put here, fc is already 0 because it is already given in the question. When x is equal to c, it is going to be 0. So fc, c minus c 0. So fc is 0. I know it's given in the question also. So fc minus h, we already done that. Minus h cos 1 by h was there. We already computed this for the limit. So I'm just writing it again. And in the denominator, you have x minus c, x is c minus h minus c. So it is negative h. Minus h gets cancelled. So cos 1 by h it is. Again, the same discussion goes. That is, this, if you put there is no h, please remember. You have to deal with cos 1 by h separately. So as I said, cos 1 by h is a bounded function. But what will happen when you put a 0 in place of h? It will be 1 by 0. 1 by 0 is not defined. You don't know what it is. So cos of not defined, how can you compute? Cannot compute. Can you compute? No, you can't. Right? Here also, on the right also, say cos 1 by h will only come. So when cos 1 by h, though they are equal, but they are not defined. In the limit, we said, when we were computing or trying to find out the continuity, I said h is in front of that. Whatever you do, cos 1 by h, whatever comes, h is 0. So everything will be 0. But here it is only cos 1 by h. So it is not defined. Cos 1 by 0, how can you contemplate or define or argue? So not defined. Both the sides not defined. So fx is not differentiable at x equals to c. That is your final verdict of this question. Is sin x, modulus of sin x, differentiable? What about cos modulus x? So for those who want to do it themselves, I have given a reference of solution. But for those who really want to know the logic and reasoning, let me tell you that we have to talk about sin x first. Sin x value is always between -1 and 1. Now, what points we find out? Wherever it is 0. So it is 0 at 0, sin 0 is 0. And wherever it is touching or crossing the x-axis, that is the 0 point. So when the 0 is coming, sin 0, 0, I can write it as 0 into pi. And sin 1 into pi, that is sin pi. Here it is 0. And then we have sin 2 pi, that also is 0. So sin n into pi. See, 2 pi also it is 0. Because it is crossing or touching the x-axis. So 0 degree, 180 degree, 360 degree. All these n pi. N is the numbers from 0 to, you can go up to infinite. And this n can be negative also. So it can be to negative infinity also. So you can call it that we are talking about the numbers which are actually the integers. So it is very clear from the diagram that all the n pi values is giving you a 0 value. So what do we do in continuity and differentiability? We always check at when this function is going to be 0. Okay. So the maximum value and minimum value of sin x, I already told you, is always between -1 and 1. Sin x or sin theta, whatever you write, it is a bounded function we already saw just now. So this is the boundation. And the value of sine for any n pi is 0. So our point of contention for the differentiability or the continuity will always be that point where it is going to be 0. And this is where the quadrants I need to show where the trigonometric function are positive or negative. So the first quadrant all are positive, second quadrant sine is only positive, third quadrant only tan is positive, fourth quadrant it is always cos positive, first quadrant all are positive. So when you go round and round, that is one round is 2 pi. So first is 0, then we have this one as pi, then we go to 2 pi, then we go to 3 pi, like this. 1 pi is 180 degree. So every time when we get n pi, we get even numbers and odd numbers also. So n pi, sine n pi, we have sine n pi plus, if you n pi minus theta, it can be in the second quadrant, or when you do sine n pi minus theta, it can be in the fourth quadrant also. Same way, if you do sine n pi plus theta, it can be in the third quadrant, or sine n pi plus theta can be in the first quadrant, right? So sine n pi minus theta, depending upon whether it is odd or even, whether it is 0, 180, 2 or 360, or likewise, you just add 180, 180, 180. The n pi minus theta and n pi plus theta will change. It will not remain same. Please remember. That is why I showed you this add sugar to coffee. You have to be very clear about this, right? So this concept is very important, because most of the solutions which I have encountered, they have only talked about n. They have not taken this n even or n odd separately, because this is very important. Because every time odd is there, the value is different. Even the value will be different. So let us see here. Left hand derivative and right hand derivative for, let us take the even. I will leave the odd one for you, just for you to have go through it, because after all you are the guys who are going to give the exam. So mod x is what? X greater than or equal to 0. Negative x if x is less than 0. Same way, sin x, if you remove the mod of sin x, when it will be negative x or positive x? When x is greater than or equal to n pi, it will be sin x, positive. That is, when you are going up. When you are going up, it will be sin x, right? But when you are going down, because when you are going down, when you are going from 0 to negative 1, by yourself, you have to put a negative sign in front of sin x, so that you don't go to the negative y-axis. You always have to be on the positive y-axis for the modulus. That is why it will be minus sin x for x less than n pi. Why n pi we have taken? Because at that n pi's, this function is becoming 0, right? So this n pi is the point where we are going to check for the left hand derivative and right hand derivative, and this we have to check separately for even and odd. So x equal to n pi, n is even. You have to show to the examiner for odd also. Please remember, you can't just say that n is any number. They are even and odd, and the different version is there, solution is there. So fx minus c by x minus c. This c is n pi here. So left hand derivative, what do we do? X equals to n pi minus h we'll put. And on the right hand derivative, we'll put x as n pi plus h. So x is n pi minus h, x is n pi plus h. So put it in this formula, fx minus fn pi. So limit x tends to n pi plus minus, you can say, on the left hand part, and x tends to n pi plus. I've written it differently. Just correct this mistake. N pi minus and n pi plus it is. I've written it, I swapped it actually. So n pi minus, so limit h tends to 0. Fx is what? Sine. Now n pi minus h, when you are on the left, x is less than n pi, so you have to use minus sine x here. Sine minus sine n pi minus h. and minus sine n pi divided by x is n pi minus h. So n pi minus h minus n pi, what will be there? N pi minus h minus n pi gets cancelled. You have a negative h here. Now sin n pi, we have started our discussion with that. Every sin n pi is 0. So you can just write it 0. Here also we'll do the same thing. Limit h tends to 0. Now which function you are going to use? You are going to use this x is greater than or equal to n pi here. So it will be a positive sin x. But in place of x, you have to replace it by n pi plus h. Please remember. Minus sin n pi is of course 0. Let me just complete it because eventually we are going to replace it by 0. What is x minus n pi here? N pi plus h minus n pi. N pi gets cancelled. You have h here. Okay, what do you get here? This also 0. So you have a negative. You can just cancel these out. Sin n pi minus h divided by h. So what is sin n pi minus h when n is even? Even is what? 0, 2 pi, 4 pi, 6 pi, like that. I told you already 8 sugar to coffee. 2 pi means just assume that it is 360. When you subtract something from the 360, that quadrant will give you a negative sign and negative sign. Okay. Sin n pi minus theta is going to be minus sin theta if n is even. Okay. This is very important. So sin n pi minus theta is going to be negative, this sin h, negative of this. You have in the denominator h. Now limit h tends to 0. You already know this, sin theta by theta, limit theta tends to 0 is going to be 1. So sin h by h is going to be 1. Negative was already there, so it will be negative 1. Similarly, on the right hand derivative, same thing you are going to do. Even we are checking, so sin n pi plus h, n is even, so it is 0, 2 pi, 4 pi, like this. So when you add something to it, n pi plus h, so you are coming here and here everything is positive. A means all are positive. So all are positive here. So this sin n pi plus h will be simply sin h. Sin n pi plus h is going to be sin h. In the denominator you already have a h. And please remember, sin n pi plus theta, if n is even, is sin theta. Please remember that. Sin h divided by h, limit h tends to 0, sin theta by theta, limit theta tends to 0 is always 1. So you have negative 1 on the left hand side, or right hand side you have a 1, that means they are not matching. You can say that this is not differentiable at x equals to n pi when n is even. So n equals even we have already checked. N equals odd. This is, I am leaving it for you. If you have any problem, just refer to this solution. But I hope after this all discussion, a lengthy discussion, you will be able to solve it. For that, you need to know where sign is positive, where sign is negative. That is the, you can say, the basis. All sign positive here. Only sine positive here, tan positive here, cos positive here. In the first quadrant, everything is positive. Sine, cos, tan, cosine, cos, tan, doesn't matter. So I hope you'll be able to do this. Or I am leaving it for you as an exercise. Or this will also check whether you understood the even part also. So 1 and minus 1 will come, and that will also show that this is not differentiable. Left hand derivative will not be equal to right hand derivative. That is showing that it is not differentiable at x equals to n pi. So the modulus sin x is not differentiable. Coming to cos modulus of x. Cos modulus of x is simply cos minus x or cos plus x. If x is greater than or equal to 0, x will be replaced by negative x. Oh, sorry, positive x. If x is greater than or equal to 0, only this modulus is only at x, not at cos, right? And when x is less than 0, mod x will be replaced by negative x. So cos x and cos minus x. What is cos minus theta? We already seen a number of times cos minus theta is cos theta only. Okay. Cos theta and cos minus theta, they both are cos theta only. So whenever we do this, it will always be cos theta. So cos theta is differentiable everywhere, because cos minus theta is cos theta, because sine minus theta is minus sine theta, and sine theta is theta. So sine theta, that's why if sine mod x it would have been, then we have to talk about sine in length. But cos mod x is simply cos everywhere. Negative positive doesn't matter. Okay, this is all about this discussion. Thank you so much and take care of yourself.